Virtually every experiment that you perform in physical chemistry will generate mathematical data that needs to be organized, analyzed, and presented. These calculations are often not possible without, or are greatly simplified and accelerated by, computer analysis. This tutorial will familiarize you with advanced software package that you can find useful for data analysis and graphical presentation. Here we'll use Mathematica, but there are other options such as MATLAB, Maple, COMSOL, and others. You want to run Mathematica. You'll see this welcome screen. If you don't see that, you can find it under Help. That's the welcome screen. You'll also want to make sure you open up the Basic Math Assistant. That can be found in the palettes. Also under Resources here, there you'll find a number of things to help your learning, but you'll want to look through, especially this Wolfram video gallery that will give you some other video tutorials. Take a look at those, and there are hands-on videos such as starting with Mathematica, a quick tour of Mathematica, introduction to the language, and hands-on start to Mathematica. Take a look at those and see what they have to show you, which will help out. Now, Mathematica is extremely powerful, but it also requires a bit of practice and learning how to use it. You have to be very careful about syntax. You might not want to use it for simple calculations, you'll think, but if you do, it's a good way of building confidence and familiarity. You will most certainly want to use it to perform simplification and evaluation of symbolic algebra, solving nonlinear equations, and performing calculus and numerical integration. One thing that's nice about Mathematica is that you have notebooks that you can use for Mathematica that can be full of information and equations that you can use over and over again. So if we start a new notebook there, right, you can enter, for instance, physical constants at the top of this notebook and save them for later use. It's convenient to add text cells and thin horizontal lines to define and organize what you've entered into the notebook. Here's an example. We have a text cell here at the top. Cells can be converted into different formats, including text. And then down here we have numerical values that I've entered for a bunch of different constants. You'll notice that they're in blue right now. They're not actually in Mathematica's memory yet. In order to do that, I have to hit Shift Enter in this box. Shift Enter. Now that they're black, they're actually entered into and available to Mathematica. Return and enter may act a little bit differently on your keyboard. You'll have to take a look at that. One of them is simply, return is simply a line feed, whereas shift return will actually evaluate data. Note also that there are two different uses of the equal sign here. You can assign a value such as the gas constant, which I'll call R gas. If you do it with a colon and an equal sign, then when I hit enter, shift enter, the value is entered into Mathematica, but there's no output that is written. Whereas when I type R gas equals 8314, shift enter, it actually prints out the value as well. So if you want to see it, use just the equal sign. If you want to suppress printing of the value, use the colon equals. Another thing about Mathematica that is very, very particular is the syntax. Let's define the temperature here, 300, and then we might want to get the product of the gas constant times T. But if I write them without a a space in between them, it thinks that's a new constant, a new variable that I've defined. Whereas if I say R gas space T, it will actually evaluate it as a multiplication. Another way that I could do that is R gas, and over here in the basic math assistant, I could use the multiplication sign NT, and I'll get the same answer. So you can construct equations and mathematical expressions using the basic math assistant to do so. Let's try some of that and try a little bit of using Mathematica for simplifying algebraic expressions. Now you can build an algebraic expression if we have something in a numerator and denominator. We'll use that here. If I had a quantity that goes into parenthesis, I've got it there. If I need to raise it to a power, that's where I raise it to a power, and something that's need to take a square root, I'll put it in there. Notice what else we have here. We have pi, for instance, and we have Euler's number E. All right, but notice this little e here that's scripted funny, that's Euler's number. That has a real value to it, right? And that the letter E from my keyboard, that is different. All right, another way to represent pi is actually as Pi, capital P. All Mathematica functions, defined functions, start with a capital letter. Okay, so we can use the basic math assistant to construct algebraic expressions such as this one. And then if we wanted to simplify that, we could use a Mathematica defined expression called full simplify. Now, Mathematica expressions, as I mentioned, they start with a capital letter and their argument will be inside of square brackets. Let's evaluate that with a shift return, and boom, we get the simplified version. It's done the algebra for us to find this really simple expression down here. Now, if I wanted to do that in a little bit more refined manner, once you become a Mathematica jock, you like doing this, I could define a function. I'll define a function by giving it a name and then putting the variable in square brackets, right, and this underscore. Then it knows what I have over here as a function, and it has assigned it the name f1. The nice thing about that is if I'm going to use this function over and over again, I don't have to keep writing it out. Instead, let's say, for instance, I wanted to do the simplification of f1. I just put the name f1 in there, f1 of x, and I can simplify it as before. Let's use another function here, another application of using a function. Let's find the volume of a prolate spheroid. All right, so if I go and I find the volume of a prolate spheroid is in terms of its short axis and its long axis, short axis R, long axis C, right? And I could type in the values for those two, enter those, and then if I want to evaluate the function, all I have to do is tell Mathematica, oh yeah, what is V of R and C with those defined values? I'll evaluate that again with a shift enter, and you'll see it gives me the value. Now, I've typed in 10 and 20 without a decimal place, and therefore it's evaluated the number as a fraction. It'll give me the maximum accuracy by giving me this irrational number over here in the form of a fraction. If, on the other hand, I add those decimal points to R and C, it now will evaluate it. Mathematica evaluates me and gives me a fully numeric answer. You don't have to set values on R and C separately. You could do that simply within the argument of the function V. Shift-Enter, and it evaluates to the numerical answer. Something kind of neat that Mathematica can do that you might want to try is that it can actually assign units to numbers. And so here we use this quantity function. We say what the magnitude is, and then in quotes we say what the unit is. And again, with or without a decimal place, if we evaluate those, we'll get the answer either as a fraction or as a numerical value. But now, because we've used the quantity function, we also get the units of the answer properly as cubic nanometers in this case, which we would expect volume to be in. Really powerful is what Mathematica can do with calculus. For instance, we can do symbolic integration. In symbolic integration, we can define a function again and integrate it. So we need to know what are the constants and what is the integration variable. So I have alpha and beta as my integration, as my constants here that'll go into that expression, and x, you'll notice x over here, that's the variable over which we're going to integrate. And we could evaluate that, and Mathematica will give us a fully symbolic answer. We could, of course, define a function, and then we can integrate with the function placed, the name of the function placed in the integration argument. And there we go. We get, of course, the same answer if we do that. Now, if we have numerical values for the coefficients, we also can do integration that way. Once we know what the functional form is like, we can define what alpha and beta should be numerically, and then we could integrate that function again. And Mathematica will now give us the appropriately evaluated form of our integrated function ff. You can also do integration to look like what you think integration should look like, right? With the integral symbol. And we can do an indefinite integral, such as that, which you'll notice over here in the basic math assistance. You can find the indefinite integral. You can also find the definite integral. For the definite integral, you put in the values between which you would like to integrate your function right on the symbol there. And now we can evaluate that and get the numerical answer of the integral under the curve between the values 0 and 6. And what does the curve look like? Mathematica can plot functions for us too. We use the plot function. The plot function, again, capital letter, don't forget it's a capital letter out front, which defines a mathematically defined function. The name of our mathematical function that I defined, and the variable, which is changing, as well as the range over which we would like to plot this function. And there it is, a nice skew distribution. Not only can we do integrals, we can do differentials as well. So differentiation in Mathematica is also possible, and we can do that fully numerically. So I'll unset alpha and beta again, and then we can do differentiation. Just a capital D will work for differentiation, or you can use a different form of that with a prime for a first derivative, the same answer there, or if we want to take the second derivative, we just do a double prime. So there you go, a quick introduction to Mathematica and how you can do algebra and calculus with it. and hopefully you'll find that useful and try to explore Mathematica some more. Remember, it is very syntax specific. Take your time and get used to building expressions in Mathematica, and it will help you a great deal.